Welcome to this session, guys. So in this session, we will going to understand network layer. So we are currently here. If you have not seen the previous video, then you can go and watch that. In that we cover application layer, transport layer, and now we are at this step, network layer. So in this session, we will try to understand network layer in detail. Have you ever got these questions that how your message is getting passed to someone who is sitting 10,000 kilometers from you? How does the message goes there, right? And when the message goes right, there are a lot of routes to take, right? For every destination, there will be multiple routes. How the packet got that intelligence that which is the best route, which will be the energy efficient route, which will be the shortest route to take to reach to the destination. And since there are multiple routes and multiple networks in the middle, what happens to the packets which are lost? Correct? Why don't this packet keeps on traversing and reach no destination? Because there are a lot of roads, right? We also sometimes, if there are multiple roads and we don't have the navigator app, we simply keep on moving here and there and we reach nowhere, right? So how does this handle all these things? All these are the interesting questions, right? All these are answers by network layer. Okay, so let us try to understand what is network layer. The network layer is responsible for finding the best path, okay, best path for your packets or data to travel from one device to another device across multiple networks. There will be multiple networks in the middle, okay. So it figure it out the best path. it performs it performs routing, addressing, okay, and packet forwarding. All these steps network layer does. So now imagine you are sending a courier to someone who is here at the other end of the world. Okay. Now this courier, right? You don't worry, right? Which path it takes. Correct. You don't worry about that. Which path it takes, how it goes there, which cities is traveled through, which road it takes in the middle, how many checkpoints it cross. We don't worry about that, right? You just want the package or the package to reach to the correct destination. The network layer provides the same. Okay. So it provides the global addressing system, path selection, forwarding through routers, and handling network congestion and failures. These are the four important functionalities of network layer. Okay. Let us try to understand these responsibilities more. Okay. So the very first responsibility, let me put responsibilities of network layer. The very first responsibility is logical addressing. Okay. Now we know every device connected to internet must have a unique address. This we know, right? So every device has a unique address. So how this is done? Correct. How this address will be given to the unique to the devices. So this is done with the help of IPv4, which is a part of network. Okay, IPv4, and there is a IPv6 also. Okay, so this is a addressing system like your house. How the address will be given? The similar way, the devices will be given a address. So two types of addresses we have. We have a IPv4 address, we have a IPv6 address. So IPv4 address looks like something like this: 192.168.1.5, and IPv6 address is a 128-bit address. Okay, this is 32-bit address. So 32 bits means 4 digits, 4 numbers. So 128-bit address. So it will be big address. Okay, it will something like, it will have alphanumeric also. It will look something like this. Okay. So it's a very big address. So why we came to IPv6? Because we have a limitation on the number of IPv4 address, because the the technology keeps on evolving, right? So we have a number of devices coming up or invented every day. So to give unique addresses to all these devices is not possible. So we are filling the short of IPv4 address. So what to do? So we have come up with IPv6 system. So that's why nowadays your laptop, whatever device you see, right? For your laptop only you see. Your laptop will have IPv4 address also and IPv6 address also. Some of the application uses IPv6 address for communication, some of the uses IPv4. But currently still dominating is IPv4. We have not yet fully shifted to IPv6. Okay. So what this address system will do? All this IPv4 IP addressing, right? We will understand in detail in this series. Okay, it's a beginner friendly series, so we will understand everything in detail. But let us try to understand now from the network layer point of view. Okay, so whatever address we got, right? Now we got this address. So this address has a capability to tell which network the device is present. Okay. So it has that capability. Similar, like if you give, right, the address like India, Maharashtra, Pune, street number 4, this way, right? So you are coming into India network, then Maharashtra network, then Pune network. So similar way, the address will have a network. From this address, one can figure it out the network, and then once we figure it out the network, then we can clearly identify the host, right? So this is the way the device will be identified. Okay. Now, one thing which I want to clarify here is we have currently IP address. Okay. And we have a MAC address, which we have seen previously. Now, the thing is IP address is not equals to MAC address. Okay. IP address is a logical address, but MAC address is a physical address. MAC address is used in your local network. Okay. But IP addresses are used in a global network. So this is the main difference. Now where are we with respect to the data transfer? So we have seen application. User has opened the website google.com. He requested something. Then application layer came into picture. It has done all its tasks here. Okay. Then transport layer came into picture. Transport layer has added the intelligence into the packet. It has divided the data into the chunks, data segments, right? And each segment has its own intelligence, its header, right? TCP header. Then it comes to now network layer. So network layer is giving this packet another power, to that is the power to identify the network or the device, the next destination device, right? So it includes the IP address to this. This is the main thing which is done in this network layer. Okay, rest other things also will be done, but this is a very important thing. Okay, now we are here. Correct. We are here. IP network layer. IP address will be given. Next responsibility, which is the second responsibility, is routing. Routing. Okay. Routing is actually deciding which path the packet should take. So there will be multiple paths, right? So which path the packet should take to the destination system. Okay. So how does this will be identified, right? Which packet to take? So the router. Now, if you are in the Wi-Fi, you will be having a router, right? So the router maintains the routing table. Every router. This is your home router. Okay. There will be many routers. When you send the request for the internet, like google.com, right? It has to traverse to, for example, US. If the server of Google is in US, it has to traverse to many router in the middle. So each router will have a routing table. Okay. This routing table holds the information about destination IP. Okay. Next hop router, then best path. Okay. And metrics, cost, distance, bandwidth, what is all these things. So what is the bandwidth of the network? Okay. If you are taking, it's similar, like if you are taking the small road, right? It will have less bandwidth. But if you go via highway, it will have more bandwidth, correct? So might be the smaller route will have less distance, but the highway will have more distance, right? So all this information routing table holds in it, and routing table helps to decide the which path the packet should take. So this ensures that the packet avoids the broken link. Okay, the packet should not take the link which is broken. Packets can take an alternate path. In case something is broken or something is congested, the packet should have capability to take the alternate path. And it also makes sure that the traffic will be balanced, right? If you are loaded with lot of requests and you are sending everybody to the same path, it's gone, right? So it try to fix that also. Traffic load get balanced. And there will be a multiple routers. Okay, so in case one router got failed, your internet will not stop working. Okay, that is another thing. So that kind of capability will be kept at each hop, each router hop, right? So in case anybody failed, your internet will not get stopped. Okay, now all this information, right? There will be multiple protocols getting used. RIP, then OSPF protocol, then BGP, border gateway protocol. Okay, so this is a very important protocol. So if somebody sitting in India want to send the message to the US, right? It has to travel through BGP, border gateway protocol. Correct, because US will have their own network. Correct. India will have own network. So for all the important networks, right, at the high level network path will be maintained at this BGP. We will understand it in very detail. Okay, in the upcoming session. Now next big task, next responsibility you can say is packet forwarding. Packet forwarding. So it is also very simple. As soon as your router, right, it receives the packet, it looks at the destination IP, because destination IP will be there in this packet, right? It's a destination address. So it looks at the destination IP, check at its own routing table, whether he knows where that IP belongs to. Okay, if he comes to know that, okay, I don't know where is that IP belongs to, but I know the next router which knows where that IP belongs to. So it will send that packet here, and this will have its own routing table. Okay, now this router might knows where the destination IP sits into which network, right? So if it knows that, then it will directly route that to that network. Okay, so that network it will route, correct, and here it will receive. So that way. So unless the router which knows the where the destination IP sits or IP located, till that point of time, the packet is kept on forwarding. Okay, unless it reaches to the router which knows the destination IP address, right? In which network the destination IP present. So till that point, your packet will get forwarded, but it's not getting forwarded randomly. Okay, it is getting forwarded based on intelligence, so that every packet forwarding bring that package to the closer of the destination. Okay, all that intelligence will be there, and there are few more things in this. Okay, the user will work with the data stream, right? He works with the data stream because for him entire file is a data, but when it comes to network, it's a small packets of data which makes that file, right? So all will be a small chunks. Okay, so when it comes to network layer, right, all these chunks get travel through the different path based on that current situation. If some route is busy, got congested, the router will forward the next packet to the another route, right? But at the end of the day, all these receives at the same destination. Okay, all these received at the same destination. And this makes this network fault tolerant. So even if one is failed, right? One is failed via this network, then again it will be resent, but with a different path altogether. Correct. So this makes it fault tolerant. Okay. Next thing which network layer does internally is fragmentation of the chunks. Let us say the data is your file. This was your file, right? It is chunked into the data. This is one chunk. Okay. Now this chunk is very big to pass through this network layer, or it is big to pass through this network. So what happens is the router which is there in the middle, it will split this packet again. It will make it two, and it will make him pass through this path. So this is called as MTU, that is maximum transmission unit. So what does this tell is every network will have its MTU. Like every road will have its size, right? So from some road only single vehicle can go. From another road might be two vehicles can go at a time, right? So every network will have a MTU, that is maximum transmission unit. So based on that, the router will take decision whether the current chunk, whatever it has received, is capable of going through that network or not. In case it is not, then it will be further splitted. So router split the packets, it makes the fragmentation of the packet, and the destination reassembles that. Okay, at the destination it got reassembled. The addressing scheme, if you are using IPv4, then the router itself can split your data packets into small chunks further. But if it is a IPv6, the router doesn't have capability. The router will ask sender only to fragment this and send. Okay, so that is the small difference between IPv4 and IPv6. Now one more concept which is very important in this is TTL, that is time to live. Now every packet comes into the network, right? It has to go through multiple routers. This is the router, it will come here, then this is a R1, R2, right? It will come here, then R3, it will come here, then might be R4, it will come here. So every packet will traverse through the different path, different routers, different hops. Now the thing is, sometimes what happens is it might goes into infinite loop. How to prevent it? So that prevention is done with the help of TTL, that is time to live. So every router, as soon as the packet receives at the router, right, the router will reduce the count. So by 1. Okay. So let us say it is 3. So as soon as it has received, the router will make the count as 2. As soon as it receives here, it will make it 1. As soon as it is received here, 0. Now in these 3 counts only it has to receive at the destination. But in case it is not, right, as soon as it came 0, now this router will say it's 0, then it will directly drop that packet out of the network. Okay, so this protect the internet congestion. Okay, now you will obviously ask why 3 only, right? So this is a predefined number. Okay, this counter will be set by your OS. Okay, so if you are running on laptop, you have a OS. If you have Windows, you have a Linux. Linux will set it usually 64. Windows will set it as 128. So the packet can take 64 hops in the middle to reach the destination. But on Windows, it can take 128 hops. So that's about the TTL. Next important concept is ARP. ARP, Address Resolution Protocol. This is important. Actually, you might be already understood this, but let me repeat it again. We have IP address. We have IP address. We have a MAC address. IP address is logical. MAC address is physical. The mapping between these two done by ARP. So ARP maps IP to MAC. So this is what ARP does, and ARP is getting used here. Okay, because when it comes to network, right, at the destination, you have a IP address of the destination, but you don't know the exact device, right? So that exact device you will get with the help of IP address. We will understand this also, don't worry. Next concept is ICMP. All these concepts, whatever we are seeing, are the part of network layer and are the responsibilities, you can say, features, you can say, of network layer. ICMP is the Internet Control Message Protocol. Okay, it's actually an error reporter of the network. Okay, sometimes your destination is unreachable, right? So in case the destination is unreachable, the message will be sent to the sender. So this will help actually in diagnosing what happens to the data. Okay. Then next concept is subnetting. This is a very important concept. Okay. Subnetting is actually dividing the network into small networks. Okay. So you might have seen 192.168.1.0/24, right? This 24, correct. This will actually split your network. Okay. We will understand this in detail. Okay. So subnetting, as of now, you just understand that there are multiple networks, and subnet will help to further divide the network into small networks. Okay. So what it helps is, it will help to reuse the IP. Okay. So you will might get only one IP address, but internally you can produce a lot of IP addresses. Okay. So similar way, you can get one IP address, but you can have multiple IP address in locally. For example, your Wi-Fi. You got one Wi-Fi. Your Wi-Fi, for example, will have one IP address, but internally you connect 10, 20 devices. All will have a IP address, but all those are the private IP addresses. Those are not recognizable outside. For example, in your building, they have 100 of flats. All 100 of flats are using the same ISP, for example. All will have the same network, right? And if you see their IP addresses of the devices, those also might be same. Okay, but those are private to them. Okay, we will understand this. This is again might be sounding complex, but it's a very beautiful concept of subnetting. There will be separate session on subnet. Okay, don't worry. Then next is a BGP. This is also important protocol, that is a border gateway protocol. Let me tell you how important it is. If BGP got failed, right, your internet stops working altogether. So BGP is actually a table, you can say, okay, which actually maintains the networks. Now there are big companies, right? Google will have, then Cloudflare will have, okay, then Microsoft will have. All these companies will have a big network, and most of the request goes to them, right? So they announce that if you want to reach out to me, you need to come to this address. Okay, so Google will also have that. So they will maintain their address in this BGP. So what happens is, this small ISP provider, whatever we are using at home, right? They somehow, this is actually at the altogether top level. Okay, from India, for example, I am using ACT internet provider. So they will have multiple hops in the middle. They at the end reach BGP. BGP, they will figure it, okay, destination address is this one. It belongs to Google. Then send that packet to the Google network. So it basically works at a global level. Okay, global level BGP works. So these are few important concepts in network layer. Okay, so now you would have understand, right? How does your data reach across the world? Because of routing and forwarding. How do router identifies the devices? It's because of IP addressing. How do we avoid the loops in the network? Because of the data packets which are not reaching anywhere. It is because of TTL. How is local delivery done? Local delivery done will be using MAC with the help of ARP protocol, that is the address resolution protocol, right? And how do we troubleshoot all this internet in case we need to track the data? What happens to the data? It's a ICMP. Okay, these are the things which we have learned in this session. So this is an overview session. We will dive deep into each of these concepts in the upcoming sessions. Okay. So meanwhile, let me tell you some shocking facts. The internet has more than 80,000 autonomous network exchanging routes through BGP. So this BGP will have 80,000 routes. Okay. Like Google, Cloudflare, all this, right? A single Google query, whatever you fire, right? It travels 15 plus routers to reach at the Google server. Okay. And coming to IPv6, one of the fact is IPv6 has 340 undecillion addresses. Okay. So undecillion is like very huge. Okay. IPv4 has how much? 2 raised to power 32. IPv4 has 2 raised to the power 32, means around 4.29 billion devices it can support. Okay, these are undecillion, means it's beyond billions. Okay, even I don't know how much, but it's a very huge. Okay, now one more thing is the routers, whatever we have seen, right? The routers, we might be thinking, hey, 15 router it has to go, it might be time consuming task, right? But all this routing forwarding, right, it happens in nanoseconds. So don't worry about that. And this BGP, about this BGP, one of the fact is, if BGP got hacked, right, this BGP, Border Gateway Protocol, if somebody hacks this, then entire, it has a capability to drop the internet of entire country. That much capability it has. So it is very, very important. Okay, so that's all about the network layer. In the upcoming session, we will understand everything in detail, deep dive. If you like this video, do share, do like, do subscribe to this channel and tell your friend about my channel. It will help me a lot. So thank you.